At the heart of constraint programming, you have the constraints. A constraint is an object that has some responsibility inside the solver when you are trying to discover solutions. The first one is the constraint should be able to check that it's feasible. And the very important one, the second one, is pruning. What we mean by pruning is removing impossible values. Let's take one example. Assume that I have x and y, and I have the constraint x must be different from y. Then, in terms of pruning, what you can do is this. You can already decide that you should remove the value 5 from the domain of x. This is what we mean by pruning. And checking that the constraint is feasible, in this case, yes, it's feasible that there is a solution. It's possible that there is a solution where x is different from y. So in terms of feasibility, we say yes. And in terms of pruning, we did 5 should be removed from x. So all these mechanisms are implemented inside algorithms, one for each constraint, which is called a propagator. And the propagator will exploit the structure and the properties of the constraint and the semantic of each of the constraints individually. The big picture of the constraint solving process is this one. The orchestrator is called the fixed point algorithm. What the fixed point algorithm will do is that it will consider every constraint one at a time, select it, check that it's not infeasible. If it is unfeasible, then we should backtrack. In case it's feasible, we will apply the pruning algorithm that will remove all the unfeasible values associated with this constraint. And this fixed point algorithm will be executed every time you explore a node in the search tree. So every time you take one decision such that x must be equal to 0 or different from 0, every time you take a branching decision to decompose your problem into simpler problems, then you will execute the fixed point algorithm. Okay, that is called here. And the search tree will be explored in a depth-first search way. To implement a solver, you will need a mechanism to do and undo the changes that the constraint will do on the domains. You need data structure to represent the domains. You need variables, objects that will encapsulate the domains. You need the implementation of the fixed point algorithms, and you need the search, typically a depth-first search, that will allows you to branch and take decisions during the exploration of the search tree. The next video will be dedicated to the implementation of the domains.